Hi guys, it's Miss Lorenz. I'm excited to go through lesson 15 with you. This is all about nets and surface area, and I know that we've done some work with nets and surface area already in lesson 15. This is more practice, and it gets definitely more complicated. So let's go through it and make sure that you have your correcting pen out that's a different color, and that you're correcting your work. You're also making sure that you have shown all your work. So I'm looking for all your thinking on your paper. So make sure that if you missed something, or if you didn't show all your thinking completely, or if you didn't label your answers, that you're doing that right now with your correcting pen. That shows me that you listened to this video, it shows me that you're learning from your mistakes, and it shows me that you're growing as a learner. So make sure that you're doing all those pieces. All right, let's get to it. In number one, we have three cardboard boxes that have been flattened out, and these are the nets of those three boxes. And we have to compare, in the first part, the surface area of these boxes. So when I first looked at these boxes, or these nets, I thought, oh, this could be confusing. And the reason for that thought is because look at all the dimensions that are included here. And so I'm really just going to need to focus on my length and width. And so you sort of have to concentrate on what information you need and not get too bogged down by all the extra information that's given here. So in this rectangle right here, it's a 2 by 3, so I know that has an area of 6, which means this one, which is identical, has an area of 6, and this one, which is identical, also has an area of 6. And that this rectangle over here on the side is actually a square rectangle, and you can see that its dimensions are 3 by 3, so that's going to have an area of 9. So then when we find the surface area, of course we sum the areas of all the faces, and so I notice here that I've got 4 6s, and 6 times 4 is 24, and then I have 2 9s, which is 18, and so if I sum 24 and 18, I end up with 42 square centimeters. All right, in the next one, I have a rectangle that is a 3 by 6, which is 18. I've got 2 of those. I've got a rectangle that's 1 by 6, which is an area of 6. So I've got 2 of those. And I've got a rectangle that's a 1 by 3, and I've got 2 of those. So if I sum up all of these faces, I get 36 from the 2 18s, I get 12 from the 2 6s, and I get 6 from the 2 3s. And 36 plus 12 plus 6 is 54 square centimeters. So remember, you should be labeling square centimeters here, since we're talking about surface area. Area is a two-dimensional measure, and so we want to make sure that we're labeling it in square units. All right, C, we're looking at a cube here, and notice that all of the faces of the cube, of course, since it's a cube, are identical, and they're all 3 by 3 faces, and 3 times 3 is 9. There are 6 faces, so 9 times 6 is 54 square centimeters. And so if we have to compare which one has the least, see how important it is to read carefully, the least surface area, we can see that it is A, with the 42 square centimeters. But in the second question, we had to compare the volume. So remember, when we're looking at volume, we have to multiply our dimensions. And so in A, we have to make sure that we're being careful about what the dimensions are. And so we have a 3, which when I put the box together in my head, I'm thinking that that's like the length. We have a height of 3, and we have a width of 2. And so it's a 3 by 3 by 2, and 3 times 3 times 2 is 18. In B, it's a little easier to see the 3 dimensions in B because they're so vastly different. It's 6 by 3 by 1. And 6 times 3 times 1 is 18 as well. So that means A and B are going to hold the same number of cubes. Even though, if you look back at their surface areas, even though their surface areas are quite different. And then in C, C has the same surface area as B, but look what happens when we multiply the dimensions to get the volume. It's a 3 by 3 by 3, which gives us 27, and it will have the largest volume of the 3 boxes. So since it has the largest volume, it will hold the most centimeter cubes. That's what that means. All right, number 2, we're looking at this lovely flat net, and the first thing we're asked is what polyhedron can be assembled from this net. Well, right off the bat, I notice that I have these rectangular faces, and so right off the bat then I know it's a prism. And since the base shapes are triangles, then I know it's a triangular prism. To find the mistakes, I'm right here. To find the mistakes in her calculation, I'm going to look carefully at each of those faces. And so I'm going to kind of get rid of this so I don't make too much of a mess. All right, so I'm going to look at this face here, and I see it's a 5 by 4, and 5 by 4 is 20. So that's correct. This face over here on the right side is a 3 by 4, and 3 times 4 is 12, so that's correct. This square face is a 4 by 4, and 4 times 4 is 16, so that's correct. So I look at the triangle, and I know that 4 times 3 is 12, but since it's a triangle, we have to find half of the base times height. So Jada forgot to divide that 12 by 2, and so the area of that triangle is not 12, but 6. And this one is the same. And so to find the surface area, we're just going to now add up the correct areas of each of those faces. So I'm going to add the 20 and the 12 and the 16 and both of the 6's to get a grand sum of 60 square centimeters. All right, in number 3, we have a cereal box. Actually, we don't have a view of a cereal box. We just can imagine what one looks like. And we have to determine the surface area. Well, the dimensions are given. It's an 8 by 2 by 12. And I want to show you how I make sure that I account for all the faces when I am finding the surface area. Kind of a quick and easy way to do that. So I'm just going to rewrite the dimensions here, 8 by 2 by 12. And then I'll walk you through kind of my thinking. And so right off the bat, I know there has to be an 8 by 2 face. And I know that all the faces are going to have a parallel identical face, right? Whether it's the top and the bottom, the side, the front and the back, they're all going to have an identical copy. And so I know there's a face that's going to be an 8 by 2, and there's going to be 2 of them. And so right here, I did 8 times 2. 8 times 2 is 16, and 2 16s is 32. I also know, so now I'm going to connect the 8 to the 12. See how I'm just like connecting those with a line? 8 times 12 is 96. And I also know that I'm going to have 2 copies of that, right? They're always going to come in pairs if it's a complete box, rectangular box. So 8 times 12 is, 96? And 2 of those would be 192. So I've accounted for that here. And then lastly, I want to make sure, so I've connected the 8 and the 2 and the 8 and the 12. So what am I missing? I'm missing the 2 and the 12. So 2 times 12, and of course there are going to be 2 of those as well. So 2 times 12 is 24, times 2 is 48. And so I'm going to take 32 plus 192 plus 48. You can see that when I first did this, I had an error under there. So let's go ahead and write these down so that I can actually see my work a little better. So I'm looking over here, 8 plus 2 is 10, plus 2 more is 12. 9 plus 1 is 10, plus 4 is 14, plus 3 is 17. So I end up with 272 square inches. All right, next I'm looking at this sort of cool shape here, right? So we had to find the surface area. So I did this by like color. So I can see right now that I'd have 6 blue faces showing, and I'd have 6 yellow faces showing, and then I have 6 green faces showing, but that I would multiply that by 2 because there's also another side that we can't see that I'm going to assume is going to be colored green as well, and so that would be 12. I know that the very bottom of that shape is going to have 6 faces showing, and then the back of that shape will also have 6 faces showing. And so I'm noticing that, look how many 6's I have. I have 1, 2, here I have 2, so 3, 4, 5, 6. So I just did 6 plus 6 plus 6, or 6 times 6 is 36. And then how would the surface area change if the top 2 cubes are removed? So if we remove these 2, the blue still holds true. Like we still need those top blue faces to be showing and counted for the surface area, but the yellow ones won't be. So we are less by 2 square units. And the last one here, we're finding the surface area after we identify what 3-dimensional figure this is. Well, you guys should notice right off the bat that there are triangular faces. So you know it's a pyramid. And since the base is a square, we know it's a square pyramid. And to find the surface area, we're going to add up we're going to add up the area of all of the faces. So I have a 16, right, for my base. And then I'm going to have to add up all of these triangles. So I know that there's 4 of them, and each triangle is found by taking 1/2 times the base times the height. The base is 4, the height is 5. And so if I take 1/2 times 4 times 5, it's taking 1/2 of 20, and 1/2 of 20 is 10. So I'm taking 4 times 10, which is 40. I'm going to add that to the 16, and I get 56 square units. All right. And that is it. That's number 5. Good timing because my battery is running low. And I'm going to go charge it up. Thanks for watching, everybody.